The future of humanity is in check. The Paris Agreement predicts that the mean planet temperature is going to increase about 1.5 degrees Celsius, severely affecting Earth's biosphere. More extreme weather phenomena is going to occur, impacting not only people but also crops, which is a huge problem since 8.9% of the global population suffers from hunger. Therefore, we must focus on our main resources. At naked eye, soil can be seen as something that's always been there. We take it for granted. However, it has been vital for sustaining life on Earth. In fact, soil participates in up to 95% of the world's food production. As a result, it is important to know and understand soils, to make better policies, and take the best decisions to protect and improve soil's fertility, mitigate erosion, and, in general, give the proper use of soils based on knowledge of their characteristics. In Colombia, the Instituto Agustín Codazzi, or IGAC, is aware that soil is not a renewable resource, and it's essential to life in our planet. As a result, IGAC makes the national soils inventory and studies its features, allowing Colombia to make decisions to fulfill its population's needs, such as eradicating hunger, food sovereignty, and climate change mitigation. Our project's main goal is to support IGAC's mission by fitting a machine learning model that performs the soil classification, using the 5 most common taxonomic orders, making the process simpler and automatic. Our project path begins with an exploratory data analysis of the dataset provided by the Institute. This analysis allowed us to understand the data and find some important issues that had to be taken into account when cleaning the data. The second project milestone was designing and building the application's front end based on Dash platform. Next, we developed the back end and used the exploratory data analysis to clean and store the data that will be uploaded to the application. Last but not least, we built and fitted different models to look for the ones which made the best job classifying orders. Taxonomic classification used by IGAC is based on the US Department of Agriculture. This classification includes 6 levels, which are orders, suborders, grade group, subgroup, family, and series. Our fitted model was built to classify the first level, taxonomic order. The back end was designed to make the application scalable, allowing it to incorporate more models in the future and integrating with other solutions. Taking this into account, the database was modeled with a flexible structure based on catalog tables that contain categories of variables and also standardized data, minimizing the influence of typing errors when capturing the data. In fact, categorical variables were recategorized to make them easier to handle and store the data. Google Cloud was chosen to be our cloud provider to expose our application and store our database, having an API to call the fitted model and perform the classifications. Several specialized classification models, including multinomial regression, stacked models, and random forest, were tested. We chose one of the random forest models, after testing more than 70 trees with different parameters. This selection process was carried out taking into account the following analysis. Regarding multinomial regression, we didn't choose it since influential points were detected by Cook's distances. Stacked models were not selected because its accuracy is almost similar to the random forest accuracy, and the latter is a simpler and faster model. The selection measure used for choosing the final random forest was the out-of-bag classification error, which is a more computationally efficient method than cross-validation method. Besides, our final model generated an accuracy of 94.2% in the test dataset, which gives us the confidence of obtaining high accuracy in future classifications. Our model was named CATS, which stands for Clasificador Automático Taxonómico de Suelos. In the future, it will be possible to classify deeper taxonomic levels by adding the necessary models to do that. Furthermore, because of the data used to train the model comes from a specific geographic region, it is highly recommended to retrain the model with a wider national sample in order to ensure the scalability of the model. The front end was designed to be user-friendly and to make the taxonomic classification process easier for the institute and the edaphologists. The dashboard is focused on a map, a tree map, and a pivot table. All of them very useful to the EGAC. In fact, these visualizations are dynamic and interactive, so they update based on filters chosen by the user. Researchers in the institute will be able to visualize and interact with new data using a predefined structure, loading to the application via the load button.
Agradecemos estos procesos porque de esta manera nos abre muchos más campos y nos abre como esa mentalidad de que nosotros no solamente podríamos estar realizando los suelos técnicamente, sino que podríamos estar vinculando toda la parte de sistemas y de automatización de la información para agilizar los procesos y para entender mucho más ese análisis que habría entre los otros conceptos como de suelo, clima, de la parte productiva y por qué no estar tratando de vincular la parte hasta económica para poder entender qué es lo que se está manejando y cuál sería la importancia para la sociedad.
This project is the work of a multidisciplinary team, which allowed having different points of view about how to solve the classification problem. In fact, our team members combine their strengths and skills to accomplish tasks and support each other. The team cohesion was a key factor in achieving our goal. The team is composed by Juan Sebastián Serrano, a geology student, Jaime Muñoz, an industrial engineer and Master of Science in Engineering, Diana Vélez, an administrative engineer and MBA, Francisco Lara, a statistician and student of Master of Science in Statistics, José Montaña, a cabinet maker, physicist and Master of Science in Physics, and Enwir Salas, a business administrator. Tropical forests are incredibly effective at storing carbon, providing at least a third of the mitigation action needed to prevent the worst climate change scenarios. Yet, nature-based solutions only receive 3% of all climate funding.